Thank you. Or I should say, g'day, mate. Hey? See, I'm multinational too. Okay, just a little bit of my background. Born and raised just over the border, just out of Lyndon, Washington. So I'm almost a Canadian. My dad spent 10 years of his childhood in Saskatchewan, so that puts me even closer. But anyway, couple of degrees in forest engineering, graduated first time in '72, came up to Canada, went to work for Macmillan Brodell, who most of you remember, or at least remember the name, as a forest engineer, planner for about 3 years, looked up the corporate ladder, didn't see a whole lot up there I wanted. So I promoted myself from development engineer to a chokerman on a high lead side for one of their contractors. Some people didn't view that as a promotion, but it got me to where I am today. But basically just a little bit there. I worked my way up through the crew, did most of the jobs, set chokers, pulled rig and hooked, side rod, yarder engineer, been a trainer, consultant, mentor, what have you for the last, since early 90s. Worked for Medill for 3 years, worked with the longline operations for M&B, Weyerhaeuser and Timber West up here. So I got a little bit of a background there. Today we're going to talk about wire rope. It's not specific to the tethered, it's just to try and give you hopefully some more information, some more understanding about what it is, how it works, and what we're doing to it, how it affects the rope. So maybe help you to make a little bit better decisions. It's just a piece of cable. It's just a hunk of iron, just a hunk of steel. It's no big deal. We use it, we abuse it. But in actual fact, what it is it's a precision engineered machine. If you look at the definition of a machine, it's just a bunch of parts, transmits force, motion, energy, one to another in some predetermined manner at some desired end. Wire rope is a machine. If you look at a piece of 626 wire rope, which is a pretty standard kind of a designation, there's 204 moving, precision engineered moving parts in that machine. That's more moving parts than are in some of our other things that we talk about being machines. Okay, every one of those wires, and it's made of wires, I don't know if the pointer works, anyway, which are made into strands, which are then laid up into a wire rope or a piece of cable. Cable is not just something you plug into the back of your TV and get a signal on. We refer to this stuff as cable as well. So if you were to look at the reel that your wire rope comes on, it might have something like this printed on it. 626 PRF, RHOL, EIPS, IWRC. What's all that mean? 6 means how many strands? That's how many strands there are. 26 wires in each strand. Okay, so we have 156 wires in the strand. So we have 156 precision engineered moving parts. PRF means it's preformed. All that means is each strand is bent into that helical shape before it's closed into the cable. That shape is given to that strand ahead of time, so that's now its relaxed state. Once in my life, I had the opportunity, and I use that word advisedly, to help a man put an eye in a piece of non-preformed wire. A piece of wire is stiff enough, it wants to be straight. So if you cut it, it just explodes. All those wires go straight. It wasn't fun. We did 2 eyes, and he grabbed the rest of it with a rigging chain and disappeared out of the yard for a little while and came back and said, the foreman will not find that one again. RHOL is right-hand ordinary lay, and we'll talk a little bit more about what that means. It talks about the construction of the cable. EIPS just refers to the grade of the steel. We have plow steel, we have improved plow steel, extra improved plow steel, extra improved plow steel. It refers to the metallurgy, and all of those things affect the performance. IWRC, it means it has an independent wire rope core. The core is a piece of cable or a piece of wire rope itself. It has 6 strands in the core as well. You can also have a fiber core. In logging, you won't see it very often, once in a great while, maybe in some straw line, but most of the time we've gotten away from the fiber core. This is just one page out of a wire rope handbook that shows just one page of the different constructions. Each one of those designs, each one of those machines is designed for a specific purpose, for specific application, for specific properties. Okay, what do we mean when we refer to the lay of a cable? You may or may not have heard the term. It actually has three different meanings. It talks about, the first one is whether it's right hand or left hand. All it means is it's the direction the strand is wound around the core. So a right hand lay rope goes from left to right, just like a screw. Left hand lay rope goes from right to left. Very seldom will you see a piece of left hand lay rope. It's good to know it's out there if you get a really good deal on a reel of rope from your neighbor down the road who's a fisherman. Hasn't been used. It looks like what you'd use, and it may in fact wind up being left hand lay. The biggest caution there is you don't put a piece of left hand lay rope on the end of a piece of right hand lay rope, because if you pull on it, then they both want to unwind in the same direction. It's like putting the button on the string, you know, and you wind it up and you pull on it and the button spins. Well, that's what will happen to the shackle, and that's what will happen to the rope, and the lay will actually work its way out. And if you've got a hand spliced eye on the end of that, pretty soon you've got nothing holding the tucks in, and the eye lets go and the tower falls down. It happened once down in New Zealand. A guy had a tower. 3 of the guy lines were right hand lay, 3 were left hand lay. The extension's the same. He knew what he was doing, but when he sold it to somebody when he retired, they didn't, and first time they rigged it up, they put left hand lay rope on right hand lay guy lines, and the tower fell down. That's a piece of right hand ordinary lay. Okay, the second one is the relation of the wires in the strands to the strands in the cable. Probably can't see that really well. This is a little bit better. Regular lay, the wires in the strands go the opposite direction around the strands that the strands go around the cable. What you're going to see is the wires look like they're running parallel to the axis of the cable. Okay, Lang's lay, the wires and the strands all go in the same direction. Just different characteristics. There again, you probably won't see Lang's lay rope anymore. They used to use it a lot on the line shovels. It takes crushing better. It doesn't do as much damage when you crush it. And the third one is probably the most useful to us in terms of monitoring the wear in the cable, and monitoring the life of the cable, is the distance it takes for one strand to go around the cable. Okay, it's approximately 6.5 diameters. It's set when the cable's manufactured. So a 1-inch diameter cable's got a lay of approximately 6.5 inches. Okay, that's going to change over the life of the cable, depending on use and depending on abuse. And we can measure that. So another thing, as opposed to diameter, that may be a little easier to do is count off 10 lays of your brand new cable and measure that distance, that length. Okay, once you break it in, you will expect it to have lengthened out by anywhere, and we'll see in a minute, 2 to 5%. Okay, beyond that, then as you use it, as you abuse it, that lay length may in fact stretch out. And if it does, it may be an indicator that something is not right. And we'll see, we'll discuss one of the things that's been discussed already this morning that can affect that lay length, and it also affects the loading in the rope. So if we look at, I'm sitting here talking to that thing, there's not even a mic in it. If we look at one strand and we start here at 1 and then count 2, 3, 4, 5, 6, 1, that distance along the cable is 1 lay length. Okay, it's just, it's set, and each, you know, any given cable, it's going to be very close to the same, but in any given batch of cables, between batches, it may change. So if you want to do that, you get your new cable, you put it on, you measure out, you know, 10 lay lengths, measure that distance, write it down in your book, and then use that as a reference. Properties, abrasion resistance, it's just the ability to withstand wear. Back in the days of the 009s and high lead, where the main line was in the dirt a good share of the time, abrasion resistant was probably more important than it is now when we're using grapple yarders and things like that where the lines are up in the air. So, but there's a trade-off between this and other things. So it just depends on what your material's contacting, the pressure between the cable and say the sheave or the stump, the grade of the steel and the construction. Larger wires is more abrasion resistant. Smaller wires, less abrasion resistant. Okay, just as a general rule. More strands, if you've got an 8-strand rope, you're going to have more wires. They're smaller, they don't take the abrasion. It doesn't, you take the same size piece out of a small wire, it's a bigger percentage than a large one. And a lot of the abrasion actually occurs on the drums of yarders. Not so much on the winch machines because it's slower. And a lot of the winch machines have groove drums, which that groove, why this industry has avoided groove drums for so long, I have no idea. Because if you ever get a chance to use them and you've used the others, and I don't know how many cable loggers there are in the crowd, but if you spent any length of time spooling rope onto flat drums, you'll know what I'm talking about. But it does a lot, occurs on the drum. Flexibility, how easy it is, how flexible the rope is, comes from two things. One, the size of the wires, and two, the construction, how they're put together. More wires, it's more flexible. More strands, more flexible. Fiber core is better, and lubrication, it's more flexible. Like we said, we've got 205 precision engineered moving parts. Every time that wire rope bends, all of those wires have to adjust their position to each other. So they slide along each other. We have moving parts, what do? We put oil, we put lubrication between them. Okay, if you cook the lubrication out of it, okay, now you're developing more friction. You're going to develop more heat, you're going to develop more wear. Whether or not we use on these tether-assisted machines, we use the cable long enough to worry too much about adding more lubrication. That's probably something we'll have to develop as we go along. Not many loggers lubricate their wire rope, and most of them that do lubricate it with the wrong kind of stuff. You don't use diesel. Diesel's a solvent. You don't use used motor oil, because why would you take the oil out of one machine and put it in another one? Okay. Heavy grease doesn't penetrate. If you're going to do it, go ahead and spend the money. Proper cable lube. It's quite thin. You put it on with a paint sprayer. It actually sucks into the cable. It will push moisture out, and the lubrication gets internal. The more flexible the wire is, the better it's for bending over sheaves, and we have a few of those in our system. Like I said, high lead, we used to use a 619 for our main rope. Now on the grapple yarders, it's 626, 631. More wires, more flexible, because that's the mode that we're using it. That's what we're doing to wear it out. Severe bending also causes severe crushing. Smaller wires are not so good for that. And the correct cable is a balance between the two. I should put it in there, but there's a chart that measures flexibility versus abrasion resistance, and it's the next chart. As one goes up, the other goes down. The more flexible it is, the less abrasion resistance it is. So it's a compromise. You're not going to get, it's like, well, probably I was going to say Fords and Chevys, but you know, there's pluses and minuses to everything. There's a balance. Fatigue. We talk about a wire rope fatiguing. And basically, fatigue, when it comes to a wire rope, is the same concept it is for you and I. You do something long enough, you do an exercise long enough, you get tired. Okay, wire rope is no different. Metal is no different. We talk about metal fatigue, and that's what this is metal fatigue. It's just repeated bending, and it's repeated tension. You can take a piece of wire rope, never bends, it's got a fitting on either end, and do nothing but increase the tension and let it off, increase the tension and let it off, and you will eventually wear it out from fatigue. It gets tired. You'll do it quite a few times. you probably want a machine to do it for you because you're going to get fatigued doing it. The tighter the bend, the faster the rope will fatigue and failure. What it means is the smaller the sheave for a given size rope, the smaller the sheave that you're bending it around, the faster it's going to fatigue. The more it's going to fatigue and eventually fail. The faster the rope is moving, the more it will fatigue. There again, I don't know if there's any grapple yard or operators here, but the rider block, oftentimes in these grapple yarding systems, the rider block above the grapple is smaller diameter than the blocks at the back end. It's just opposite to what you really want, because that cable's going through that rider block at twice the velocity that it's going through the tail blocks, right? The grapple's coming in and the cable's going out, that cable's going through there twice as fast. So you're putting more wear and fatigue into that cable with the rider block than you are with the block or blocks at the back end. Okay, close couple reverse bends, all that means, and we don't have many systems, I don't think, in here that do that, but where the rope goes around one sheave and then immediately goes around another one. That'll half the life of your line, because the rope isn't back to where it started before it hits the other one. In fact, if those blocks are not, say, about 12 feet apart, 2 blocks will do more than twice as much wear as one, because the rope hasn't gotten back to where it was before it hits the next one, and the fatigue is more. That's a well-worn piece of rope. Some of us have seen it, but that's not necessarily an abused rope. That may just be plain wore out. Okay, you got a lot of life out of it. It went around the sheave a lot of times, but that's what a wire rope actually should look like when it's totally wore out. Those are fatigue breaks. They're square. Crown wires, they're broken. That's fatigue. There's another kind of fatigue that is more important to us in terms of the tethering, and that's what we call vibrational fatigue. Any energy that travels down that cable, vibration, wiggling back and forth, shock loads, that's energy, and it travels down that cable until it hits something solid. That solid is your infitting. It's that poured socket, it's the wedge ferrule, anything that constricts that cable, that energy hits that just like hitting a brick wall. And all that energy dissipates into the steel and it will fatigue. That's why more than one broken wire at that point is rejectable. So if you've got a poured fitting on the end of your tether line, when you do your inspections, you look right around where the cable goes into that fitting, and you're looking for one broken wire. And when you find one, you cut it off and you redo it. Because one broken, yes?
With how far back from there would you cut it off? It just, would you want to go full wavelength or?
Yeah, I don't, honestly, I don't know. I've never seen anybody say, well, you cut off this much. But I would say, yeah, a lay length or 2, Just get away from that point, because if you think about that energy coming down, it just hits there. You've restricted all of this. There's no place for that wire to go. So right there is it, any bending, any energy, all of that. But yeah, a lay length or 2, just get away from that fatigue metal. That's an off the top of my head estimate, not based on a reference. We don't have standing ropes on these tethered machines, but if you have a wire rope that goes through a sheave and it sits there in that same place all the time, it's not raised or lowered, it just sits there. Where that goes over the sheave is another place that vibrational fatigue will get you. You're bending the rope, you've constricted it, that energy dissipates there. Okay. More than one, like I say, more than one broken wire is rejectable at that point. Crushing, just capacity to withstand smashing or flattening. Anytime, if a concept that you need to get in your head. Anytime you distort the structure of the cable, you change it from the way it was manufactured, you're doing damage. So if you crush it, you've disturbed, even though you've got no broken wires, you've disturbed that structure, you've changed the way those wires share the load, okay, and you've weakened it. Bigger wires, more crush resistant, wire rope core, swedge, die form, power pack, plastic filled valley rope is more crush resistant. Where you get it, multiple layer windings on drums, and there are ways to change those wear patterns. If you were going to leave that rope on there for long, if you start seeing crushing at crossover points, if you pull that wire rope off, and I've heard two different criteria now, if you cut a wrap and a half off of the anchor end of that rope, re-anchor it, you change that crossover point. You change the point of wear. And the last one I heard, actually just read it last night, is 20 diameters. So 20 diameters is going to be a whole lot less than a wrap and a half, so maybe that's cheaper, I don't know. But they figured that would change it enough. But
I didn't understand that. So on your anchoring cable on the drum, you want to be changing that more often?
it's only if you're seeing crushing at the crossover points. Only if you're finding it as a problem. Like I say, it's probably not. We're probably not leaving the rope on the drum long enough for it to become a problem in this application.
So, but on a yarder, you're saying if you're looking at your lay and you're noticing some wear, then cut 20 wraps off.
20 diameters off the anchor end of your rope and re-anchor it. All that you're doing is you're moving that wear point, so it's not always happening at the same place.
So, say when you're upending your lines on a yarder, it would probably be worth just knocking that off anyway.
Well, yeah, if you're in for ending it anyway, you're doing that. But if you're not going to end for end it, if you're on your yarder and you're seeing that, yeah, then just if you pull it out to the end, whack that off, re-anchor it, put it back on. If you're in for ending it, you're doing it anyway. Okay? Improper sheave grooves. The grooves in your sheaves will wear small. As they wear, they get tighter. They don't wear big, they wear small. So that line is cutting down into that sheave. So the line that you just took off may still fit because it wore itself a hole. But the new line is a little bit bigger because it hasn't been pulled in and it hasn't worn, and now you're trying to cram that wire rope down into a V, a place that's too narrow for it. You can do quite a bit of damage. So periodically, you know, I don't know if your wire rope manufacturers give out the old sheave groove gauges anymore where you get them, but you can get a sheave groove gauge, say that real quick, and check them once in a while. You know, not every month, but once a year, every time, you know, when you change lines, whatever, just make sure they're not wearing tight. If you change the diameter of the rope on your machine, you have to think about maybe part of that process is changing the sheaves to get one that's grooved for the line. If you've got multiple layer windings, you've got to put the bottom layers on almost as tight as what you're going to be putting line on top of it. Because if you don't, the extra tension in the line above it will crush what's below it. Just shows a picture of multiple distortion sets or kinks. If you kink a rope, you've permanently damaged it. You can hammer on it all you want, but to get that kink, you've actually stretched wires. You stretch a wire, it gets smaller, it gets weaker, you've done permanent damage. It's pretty much preventable. One of the phrases that I like, and I thought of it a couple of times in the discussions earlier, is there is nothing idiot-proof to a properly motivated idiot. we have enough incentive, we can get around just about anything. And like also was pointed out, most of the incidences that have happened in this game have been where somebody bypassed something or forgot. Not necessarily intentional, it's not malicious, it's just we get comfortable and we forget. Turn the system off, walk up the hill, reach around, grab the chains, put it over the other side of the stump, turn around and walk back down the hill. What did we forget to do? Turn the system back on. When we turned the system off, it set the brakes. Okay, an operator did that. He would turn around, walked away, walked through the eye. He stayed there because he wasn't hanging on it. But yeah, that's where a kink starts. You know, if you're cable loggers, you know, you get a coil of straw line from the factory and it's in a nice beautiful coil and you grab the end and you walk away. Pretty soon you got a whole bunch of these loops. We call them other things, but they're loops. Laying down there, and instead of walking back and throwing every one of them out and turning the cable, taking the twist out of it, you just give it a bit of a jerk, and then you got a jerk on both ends. And we get something like that. That's damaged. How much? I haven't tested that one. I don't know. I haven't put that one in the test bed. But you've done permanent damage. It's not as strong as it used to be. And on these systems, at the end of the day, somebody's life is hanging on the end of that rope. Not hanging, is being assisted by that rope. Traction assisted, okay? But you are. You know, your man or you are depending on that rope for a certain amount of assistance, and that factor of safety is so that if things go wrong, if you do everything right and something goes wrong that was inadvertent, that rope's going to hold. You kink it, and now you just reduce that factor of safety. No broken wires, but if you can see that there's a kink, a wow in that line, there's been damage done. Wire rope stretches in one of three ways. Initially, when you buy it and you start to use it, you have what's called constructional stretch. As that rope wears in, the wires bed into each other, the strands bed into the core, the strands bed into each other, and the wires start to share the load more evenly, it will stretch somewhere, depending on the construction, between 1/4 and 0.5%. Doesn't sound like a lot, but if you look at a 2,000-foot piece of rope, it's going to be 5 to 10 feet longer than what you bought. Don't tell your wire rope salesman for that, because he'll charge you for the extra 10 feet. But it's going to get longer. Like I said, if you measure the lay length before you put it on the machine, and then you measure it again 2 weeks from now, it's going to have extended out. It's gotten longer. That stretch is permanent, okay? And it actually the strength of that rope will actually increase. For probably anywhere 50 to 80% of the life of that rope, if you cut a piece out of it, if you haven't damaged it, you can cut a piece out of it, put it in the test bed, and it will test stronger than the certificate that came with the rope. Because that bedding in process, the rope actually gets stronger. The wires share the load. A wire rope guy told me one time that brand new rope, 60% of the wires are taking 80% of the load because they're not sharing. We haven't got a team going yet. Some people are dragging a little bit. They're not in shape. They haven't kind of got focused yet. Okay, that's permanent. That happens, okay. After that, wire rope is like a spring or a big rubber band. Okay, I got a big heavy rubber band and I hook it over my thumb and I walk up to my friend here and I pull it back. Does he get nervous?
Right, I do.
Yeah, okay. That's what you're looking at when you're looking down a piece of wire rope. It stretches. How much? If you want to plug it in, there's the formula. But if you've got a 1-inch piece of rope start out at 22,000 pounds, and you increase it to 44, you'll actually stretch it about 7.5 feet. That's elastic stretch. That's just like the rubber band. You let that off, it's going to come back. Now, I started out at 22,000 because from 0 up to a certain percentage, it doesn't act exactly like a spring. There's some things going on there, but it's still stretched, okay? So the first 22,000, you probably got 10 feet of stretch out. The next 22, you got another 7.5. So now it's 17.5 feet longer than it was before you started pulling on it. Okay, if you let go of the end of that, or it breaks, where's it going? It's going straight back down where it came from. So you don't stand in line with a fully loaded piece of cable. That's where it's going, okay? 44,000 pounds, that's not up to safe working load yet. You're looking at, you know, so probably by the time you get to safe working load, it's, what I say, 17, probably 20, 25 feet longer. That's safe working load. You go up to the elastic limit, which is double that. That's another 25 feet. Okay, big rubber band. Okay, but it's just understanding this is what's happening. The other thing that this gives you, though, is it's a bit of a shock absorber. A spring is a shock absorber, right? So it's going to absorb some of those peaks and valleys. You're sitting there bouncing on a spring. Okay, that stretch is recoverable up to about 60 to 65% of the catalog breaking strength. At that point in time, you start to do damage. Now it starts to stretch inelastically. In other words, it starts to get, it's still getting longer, but when you let it off, now it's going to be longer than it was when you started. What you've done is you've stretched wires, and to stretch a wire, you've only got so much material. So for that wire to get longer, it has to get thinner, right? It gets thinner, you've got less cross-section, you've got less strength. Okay, so every time you go beyond that 2/3 or the elastic limit, you've done permanent damage, you've weakened the rope. I like the point you made about the fact that when the rope breaks, most of the time it's not what you were doing at the time that it broke that broke the rope. It's what you were doing an hour ago, a day ago, a week ago, or maybe you've been doing it for the last 6 weeks. Just overloading it just that little bit, that little bit, that little bit, gradually weakening it. Okay, when you bend a wire rope around a corner, whether that's a shiv or a stump, or a sheave or a stump, or whatever, you add stress. Those wires have to move. Okay, they're not sharing the load exactly again, so you add stress. If you bend it around a, say a 30-to-1 D over D ratio, in other words, the diameter of the shiv is 30 times what the diameter of the cable is, you lose about 5%. In other words, the rope will break at 95% of its breaking strength as opposed to, okay, you bend it around a 10-to-1, and now it's going to break at about 85%. Okay, what's the first thing that that rope hits when it comes off the sheave of your, off the drum of your tether machine? Hits a shiv, doesn't it? Okay, depending on the size of that shiv, you are now somewhere between, well, I don't think any of them have a 30-to-1, so you're probably somewhere between 85 and 90% efficiency on your rope. So you're at that point already. The first shiv you go over. Now it doesn't, each shiv doesn't take that much more out of it. It's whichever one's the smallest is going to weaken the rope the most. So when you're looking at a system, and I won't mention any names, but one of the manufacturers had, over the top of the boom, had 2 small rollers at one time. And we had a bit of a conversation, and I think that those 2 small rollers has been replaced with a larger sheave, right? Okay, I didn't mention any names. Okay, but just little things like that. We don't think about it. Well, it's just, you know, it's only bending a little bit. Doesn't matter. That bend around that radius, if you bend a rope around a pin of its own diameter, so you get down to a 1-to-1 D over D ratio, half the strength of your rope's gone. Okay. Doesn't matter whether it's a shiv or a stump. Just the fact you bent it, you've reallocated that strength. Okay? The drier the rope is, the more stress you're going to add. So this is for that chart's for a nice, well lubricated rope. But the harder it is for those wires to move in relation to each other, the more strength you're going to lose by bending it. Okay? So large wires, more stress, more wires, less stress. Bending causes stress. Now this is an interesting picture. I put it in just because you got the rope coming in and going back out. But if you look at the way that rope is laying in that block, and I don't know what's happening down here, but for some reason that block's not hanging straight with the rope. Okay, it's coming in off the side, and I don't know whether it's going off the same side underneath or not, but just things like that. You look at that and you say, there's something not right there. Okay, and with that rope moving under the tension it is and the speed it's moving, there's additional wear being put into the rope and also into the shiv. The side of that, one shiv of that block is going to wind up thin eventually. Okay. Wrap angle. Doesn't matter how far around the shiv you go. Basically, and sometimes I ask the question to get people to vote, but I'll just tell you. As soon as you put one lay of that cable in contact with whatever you're bending it around, okay, all of the wires are contained in that one lay. So in that one lay has formed to that radius, okay, from there on out, to go further around the shiv, it doesn't change that bend. All it does is it just keeps going. No different than that rope going onto the drum. You bend it into that arc, and then it just goes around and around and around and around. It just sits there. So once you've got one lay of rope in contact with a shiv, it doesn't matter how far around you go, you've done one bending cycle. You've bent it once, and it straightens out. So both of those situations, you're putting the same wear, the same stress into that wire rope. Okay, if you want to go 180 and you use 2 blocks instead of 1, then you bend it once, it straightens out. You bend it a second time, it straightens out again. You put twice as much wear into that rope going around 2 blocks as you did going around 1. Because once you bend it, the rest of the way around doesn't matter. Okay? Like I said, and if you don't have those blocks 12 feet apart, then you're actually putting more than double the wear into it. Okay, make sense? Or you'll take my word for it, right?
Brian, can I, when you're spreading your blocks, say on a grapple yarder,
Yep.
now transfer that idea to a tether machine and multiple stumps. Do you have to, if you're going to say multi-stage around a couple of stumps, do you have to keep it under 45 degrees and further than 12 feet apart to reduce that line stress?
No, basically, no, you don't have to keep it under 45. You just, two things. One, you want a big enough block, and 2, you minimize the blocks. If you need 2 stumps for the strength to distribute the load, then you use 2 blocks. And it's the same one, with any system. If you need 2 blocks to keep from getting line wrap, you use 2 blocks. If you need 3, you use 3. But you don't put them in. You don't put 2 blocks in because you think you're doing less wear. Yeah. When you could get away with 1.
Yeah, because on a yarding system, you're going to introduce, with the line wrap, you're going to introduce more wear than you are than if you improperly put 2 blocks in generally. But with a tension, like I say, a traction line, EMS, whatever you have, when you hook out around 2 stumps and put like multiple different angles on the cable, how does that, do you have to be under 45 degrees to reduce damage to a cable on a traction line?
No, I would say there again, you hang as few blocks as you need to. So you hang however many blocks you need to go around this corner or to distribute the load, but you don't hang any more than you need. In other words, I would go around 1 block at 90 degrees before I'd go around 2 at 45 if the stump will take the load, because you're still only going through 1 bending cycle. Okay, and what happens from 0 to 45 is some amount of that full bending cycle that I don't have a number on. So I wouldn't go 2 blocks just so I could keep it under 45. I would go minimize the number of blocks. Basically, bottom line is just minimize them and make sure they're big enough. And we'll see what the D over D, well, we saw a little bit about what the D over D ratio does already. Fatigue life, in other words, how fast you're going to wear it out just in terms of the wear that you're putting into that is a function of what they found, tests, and everything else. It's basically a function of the diameter, the D over D ratio squared. All it says is if you double the diameter of the block, you've halved the D over D ratio. Half times a half is a quarter. So you've quartered. So if you double the diameter of the block, all other things being equal, you're going to put a quarter of the wear into that wire rope. Usually we're going the other way. We say, well, the 18-inch block is too heavy. You know, I can't lift it anymore. Okay, so I'll go to a 15. Well, you take 18, the ratio between 18 squared and 15 squared, and you'll find out that the difference between those is about 44% more wear in the cable by going to a 15-inch block. The speed we're going with this system, probably not as big a consideration as in a yarding system. But if you are looking, I mean, this stuff applies to both. But if you're looking at the rider block on your grapple yarder, okay, you don't have to carry it. The machine carries it, the cable carries it. You go from a 15 to an 18, you get 44% less wear into that cable. So it's not just, you know, doubling the diameter doubles the life, it's 4 times the life. Extending cable life. What do we do? Or what do we do to avoid it, to make it last longer? First, proper storage and handling. You get a reel of rope. You don't need it right now. You know, if at all possible, don't just set it in the ditch, you know, by the side of the road and leave it sit there for a month. Okay, when you finally put it on, there'll be a little red, in the lubrication, there'll be little red spots in there. What's that red stuff? Rust. What's rust? Iron oxide. Where'd the iron come from? Out of the cable. Okay, simple things like that. Protect from corrosion. You don't want it in a corrosive environment. Interesting thing I was reading the other, last night, I guess. It was a safety line, a stainless steel safety line that you clip your harness into when you're up on a structure. And one day it broke. Nobody was hanging on it, nobody was pulling on it, it just broke. What had happened was there had been an airline broke, and it was hydrogen peroxide, and this rope had gotten basically doused in hydrogen peroxide. They cleaned up the mess, fixed the line, everything, nobody thought anything about it. Well, apparently hydrogen actually will penetrate into that iron, that steel, and corrode it, basically breaks it down. They went into a long explanation of why, but I didn't understand too much of it. But sometimes things that we don't think about, you know, can impact what we're doing. Okay. When you're putting line on a machine, you go from the top of the reel to the top of the drum. Most of these machines the drums are overwound. So you go from the top to the top, or you go from the bottom to the bottom. If it's an underwound drum, you go from the bottom of the reel to the bottom there. If you do it like this gentleman on the bottom here did it, he went from the top to the bottom, what you're doing is you're putting a twist in that rope. Okay, the rope has a memory. And it doesn't want to spool as well, and it actually wears faster. Just something as simple as that. Okay, so top to top, bottom to bottom, you're fine. Okay, the other thing, and I don't think I have a picture of it, but I'll since I thought of it, you want to redirect the rope through from the reel to the drum, and you got a block there. You got a nice little 6-inch Tommy Moore block. If you put any kind of pressure on that 6-inch Tommy Moore block, that the D over D ratio is so small that it will do to that wire rope what you do to a birthday ribbon when you run it over the edge of a scissors. It'll curl it. I saw it done with an 1 3/8 Skyline one time. They pulled it on, wanted to put it on tight, hung a block on the blade of the dozer, run it through there, and when they got it on there and they relaxed it, going up the tower, there's a big curl in it. Okay, what causes that? You've actually stretched the wire on one side of that rope. Okay. Break it in properly. We talked about a little bit about that, but on the tether machine, you put a new rope on, and if you can, walk it down under, and we're not running high tensions, but walk it out and walk it back in, and maybe do that 2 or 3 times. Or if you can't do that, at least try to use it on. Try to schedule it so you're using that on the flatter slopes, so you're running lower tensions. What you're trying to do is you're just trying to work it in. You're trying to run it over the shiv, let those wires all even out, share the load, bed in. Okay. Logging, we upend the lines periodically, and if you're going to do that, I don't know if anybody's doing that with your tether machines. If you're going to do it, you're better to do it sooner rather than later. So use it for a couple of weeks, maybe a month, and then upend it. You're putting the piece that's been broken in on the bottom. It's going to be harder, more compact now. It's going to be stronger. It'll spool on there, and then what you're putting on top of it is not so much different in diameter that it's going to cause a problem spooling. Now, I'm not sure, I haven't talked to anybody about the grooving on these drums, how much space they leave between the wraps, but when you break that line in, the diameter is actually getting smaller. Okay? If you're on a smooth drum, if you end for end it too late, you put that rope on the drum, it forms a pattern, and everything is good until you start stacking the rope that's been on the drum on top of it. It's bigger in diameter, and it's bigger enough that pretty soon it starts to crowd itself. It's trying to get into a space that's too small. So if you're going to end for end it, do it sooner rather than later. We talked about a cutoff program. That's on the anchor end. Lubrication. If you're doing a lot of redirect on stumps and cooking it, we did some testing down there in Washington with CNC and with Kroom's machine, both the 1 and 2 line, and we just doing our testing, we got the rope hot enough that the oil was starting to squeeze out. Like we didn't have a heat gun to see, but you couldn't grab a hold of the cable and hang on to it. You couldn't leave your hand on there. You could grab it, but you had to let go. And I don't know, what's 60 degrees centigrade in terms of Fahrenheit? 130, 120, 130, 140, in that ballpark. So it is something to think about. Dragging it down the road, we do that with guy line extensions all the time. But if you don't think that causes wear, do it at night. Just don't do it in the middle of fire season. Quite a fire show. Overloads and shock loads. A lot of, what I was hearing this morning, a lot of it I think helps us to, as an operator or as, training operators, is the more you understand about how the system it works, the more you can avoid the shock loads. You say, okay, I'm in a situation now where if I do this, we're going to shock load the rope, but if I do something a little bit different, I can ease that. One of the things that came up in some of the tension measuring things is the spikes when you change direction. Okay, if you think about what's happening when you're redirecting around the stump, if you think about what's happening in the stump, you got the wood fibers. Okay, they're like this. Okay, and the wire rope wears its way through, and you're pulling in this direction. Now all these fibers are bent this way, right? You've cut through them, you've bent them this way, they're surrounding that cable. If you stop and change directions, what has to happen? They're going to turn and go back the other way, but they're too long. So they're going to everything's going to get tighter as they turn direction and start back the other way. So it's just that stopping and then going back the other direction that may, that's kind of what I'm visioning happening inside that stump, why it's doing that. I very much believe that if we do more measurements, more work, we'll find there's a whole lot more difference between the block and the not block. I'm going to do some in a very limited, small scale thing, but I think it's something that we need to investigate. I'm coming from a cable logging background, okay? And one of the things that we worked very, very hard at was keeping the line off the ground, keeping the line from burning into trees, burning into stumps. If you've ever ran a yarder, if the haulback is burning into a tree or a stump, it's not very long before you know it, because pretty soon you start to get a pulse, and pretty soon the whole tower is going like this as you're trying to pull the rigging back or you're trying to pull it in. But what's happening is that line is moving and it's locking up, and it's moving and it's locking up. And I've not done it personally, but I have talked to loggers who said they've actually broken their haulback just trying to pull the rigging back, because it finally got so tight that they couldn't pull it. And you just keep pulling back on the throttle, and nobody says anything, and boom. There's a lot of things happen. The peaks that we're showing, these little peaks, like was pointed out, you stand there and watch it, and that cable looks like it's just going through the stump. But you look at the tension traces, and it's going like this. So there's a lot of things happening there that we can't necessarily measure at this point, but I think we need to be aware of them. Burning it over rocks and trees. This presentation was, the basis of it was made for loggers, but when you burn through that tree, what's happening? You generate enough heat. The very outside of the outside wires gets extremely hot. And we may, if we have time, look at a real short video, but when we were doing the tethered thing, we talked about the difference between steam and smoke. But I saw that stuff turn from steam to smoke. Smoke is blue. When the steam's coming out blue, that ain't steam anymore. That's smoke. And I was going to check on my phone to see at what temperature wood starts to smoke, and I haven't done that yet. But so you're generating a lot of heat. What happens is the very outside of that outside wire gets extremely hot. Okay, and as soon as it comes out of that stump, because you've got this huge mass, relatively speaking, a huge mass of cold steel behind it, it cools. So yeah, you can put your hand on it, but if you could sneak inside there and stand at the interface of that wire rope and that wood as it's going through there, you probably couldn't. Okay, well what it's doing is it's changing the metallurgy of the outside of that outside wire. You're creating a very thin skin of martensite, which is a very hard and brittle metal. Okay, and then you go along and you bend it. Okay, anybody ever skinned their knuckle? You skin your knuckle and it starts to scab over, and you got a nice hard scab there that's healing pretty good, and you reach out and you grab something. So you bend that. What happens to that nice hard brittle scab? It cracks, right? And it doesn't just crack the scab, it cracks down into that soft stuff that's below it, right? Okay, we've all done it. Well, that's exactly what's happening with the wire, with the metal in the wire rope. That crack will propagate. Okay. It's not a matter of you don't do it, it's a matter of you control what you're doing. When you can avoid it, you avoid it. When you can't avoid it, you understand what you're doing. You make conscious decisions. Spooled properly on the drum. You know, with the groove drums and the controlled tension, these tether machines are a whole lot more forgiving than a yarder. Yeah, there we go. No extra blocks in the layout. Minimize the number of blocks if you're going to use them. Economics of extending cable life. You know, what's it worth to get another day or two or three or a month out of your rope? You can do the numbers. That's pretty easy. Basically, the tighter you run it, the faster you're going to wear it out. Duh. Pretty profound statement. Okay. Relative service life design. This, like I say, this is relative. If you run a 3-to-1 factor of safety, you're going to get a life of, relatively speaking, 60. If you run a 6-to-1, you're up at 120. So by halving the tension, you doubled the life. Okay, do you want to do that? Probably not, because all the extra turns you're going to get by running 3-to-1 will more than pay for your skyline. But it's still something to consider as to where you run. We saw this on a fancier graph with colors and everything else, but basically the same thing. In logging, we use a third as safe working load, 50% is a fatigue limit. You go beyond 50% all the time, and your line life will get shorter a lot faster. Okay, elastic limit is where you start to do damage. It's where you start to stretch wires. And I used to have down there 100% as a catalog breaking strength. Well, you're never, in an application, you're never going to get 100%. Because you've always got a termination. Okay, spliced eye is 80 to 85%. The only one you can put on there that's going to give you 100 is a poured socket, a proper poured socket, done well. We talked about efficiency, that overshift. This gives you some numbers. 30-to-1 is 93, 10-to-1, 15-to-1 is in the mid-80s. So going over that first shift gets you down about to where a hand spliced eye will get you. So there's not really any point in talking about putting 100% fitting on the end of your cable when you can only get 85% going over the first shift. We talked D over D ratio, so those are the numbers for the 44% increase in life. Blocks too close together. Abrasion, there's in your code, they have criteria. Used to be 12, in Oregon, it used to be 12.5% of the wires. Now they've backed off to basically come in line with construction industries and everybody else. Basically, it's 6 broken wires in one lay, or 3 broken wires in one strand in one lay. So it's not very many. It doesn't apply to chokers. Chokers are good until you got 2 pieces. Well, they're not good, but they're acceptable, okay? We talked about charting diameter versus time. Probably the easier one to chart is lay length versus time. Kinks, bird caging. The bird caging, I don't know if you know what that is referring to, but you've got strands that are standing up away from the rope. And it's something that you may actually start to see. Because what happens is when you drag that rope through a stump, not only is it sliding through there and creating heat, but that tight fitting in there is trying to actually follow the strands. So it's trying to unlay the cable. It's trying to twist the cable. You bring a turn into the landing with the haul back on and you slack it off just a little bit, and the eye at where the cable, the haul back hooks to the back of the carriage spins. That's an indicator that you've got a bind somewhere in your line. But what happens when you twist that cable, if you think about it, the core is going straight down the middle. It's not bent. Okay, the strand is going around like this, but if you untwist that strand, it's going to get longer. So you're pushing that slack It's being pushed back up the cable. And it will be interesting to see if we actually start seeing some of that happening. We talked about localized condition, drum crossovers, flange points, infittings, fatigue cracks. Normally they're straight across. Okay. Do any of the tether machines have smooth drums? Okay. Hi, Lars. Didn't see you. Okay. So, any of you have cable logged have put rope on smooth drums. Very quickly, the first layer wants to be snug, but not singing tight. Now, this is not guaranteed 100%. This is just what I've found and others have found works more often than some of the other things that we used to do. The first layer doesn't want to be singing tight. It wants to be snug, it wants to be tight, but not singing tight. Because you're putting that round cable on a flat surface. And if you pull too tight on it, you're going to start to squish it. You're going to start to distort the structure. Okay. First one goes on. You get over to the other side, and that last wrap wants to either be tight against the flange, or you want about a half a diameter gap. Because the first layer that climbs up wants to sit at the same height as the rest of the layers as that second layer comes on. If the gap is too small, it's going to sit up high. If it's too wide, that's going to sit down low. So you've got to get that gap. If the gap's not right, you go back over to the anchor, you pull it off, and you do something different. Now maybe the first time you had two people standing there pushing it over and somebody tapping it with a hammer. Okay? Give one of the guys a rest and the guy with the hammer a rest. Just hold it over. You don't have to change how much room each wrap takes when you got 20 or 30 wraps to change that gap just enough. Okay? If it climbs up, if your gap's right, pull off the last 3 wraps, put the tension on, and put it on, and it should go. It'll go on, the second layer will go on, the third layer will go on, and if the first layer is not right, when you climb up off the third layer onto the fourth layer is where you're going to see the problem. And if you've got a problem, what do? Go all the way back down to the bottom. Okay? And this is the second to the last line there is what happens when you have to start over. Okay? If you've got groove drums, you just anchor it off, put the tension on it, spool it on, go to work. I had a contractor down in Oregon tell me he put lagging on 3 drums on a 739 Skagit. Cost him $21,000. He did it on the basis that he was going to pay for that in 2 years. He said 6 months, he had his money back. Just from time saved, time and wear on the lines. Breaking in, we talked about breaking in a new rope. We don't splice. I don't think we're going to do any long splicing on tether ropes. But just as a point of information, if you do any long splicing, I don't know about the BC code, but Washington and Oregon, they've got a chart in there. For every diameter of rope, they've got how long of a piece you should unlay to do a long splice. If you divide the lay length into that distance they give you, every one of them comes up with the same number. In other words, you undo the same number of lays regardless of the diameter, and that number comes out about 40. It comes out 37 to 38, but I just rounded off to 40. So if you unlay 40 lays, either way, doesn't matter what the diameter is, you have a code compliant splice. So that's just a little tidbit of information that maybe will help you. Some numbers that we come out, some of these are out of the book, some of them are off of the testing we've done. A hand spliced eye runs 80 to 90% of the catalog breaking strength. A swedged eye, and I'll get some pictures here in a second, is 90%. A swedged socket is 100. White metal or resin is 100. Wedge socket, that's the one with the wedge in it. The cable goes through, you got a wedge, it pulls back into itself. 60 to 80. Wire rope clamps is somewhere around 80. That's if they're done properly. Okay, that's a swedged eye. That's a swedged socket, so it's pressed on. poured fittings, a wedge socket, 75 to 80, and that shows the proper way of doing it. You don't clamp the dead end of the line back to the live side. You will not find anybody who manufactures a wedge socket that will tell you to do that. The only ones who tell you to do that is Medill and Thunderbird in their operator's manual for their grapple yarders. Cable clamps, never saddle a dead horse, right? You don't put the saddle on the dead end of the line. We did some pull testing of lines. This will be interesting, bouncing this one off of you because this comes back in the WorkSafe BC website. They've got a splicing manual. And this eye was spliced the way the manual says. And to do that, you tuck the core last. You tuck the core as a 7th strand. When we pull tested that, we found out that doing it that way costs you about 7% of the strength of the splice, as opposed to tucking the core with the 4th strand, just tucking it once. Once I got over the shock of that, because this is the way I learned up in Sprout Lake how to splice. I did it that way for 40 some years. After we got done testing it, I had to change. It's still strong enough. It's not going to fail in normal use. But if you think about it, I said earlier, if you distort the structure of the cable, you weaken it, right? The core is bigger than a strand, and it's harder than a strand. Okay, so it's more of a distortion. Where you tuck that through, right there, that last 2 tucks, that's the first distortion you get in that cable as you come up to the eye. And it's more of a distortion than a strand is. Okay, I'm not saying don't do it this way. I'm just saying all the testing we've done, it costs you about 7%. Okay, this is a West Coast Logger's Eye 3-tuck core with a 4. So the core is up here. It's just tucked once in with strand number 4. When you tuck, before you tuck strand number 4, you put the core through there, you put 4 in there alongside it, and then you forget about the core. You only tuck it once. It doesn't add anything to the strength of the eye. You could cut it off and not tuck it at all, and it wouldn't change the end result. Okay. Interesting, we come out round strand, that tested out about 80%, swedged was 90. Very small samples, not statistically strong sample set, so we can't go too far with that, but it was pretty consistent. West Coast Logger's Eye 4-tuck, the core is 7, was 77%. It was down, it wasn't quite the 7%, but it was less than. The 4th tuck did nothing for our strength. It's one more tuck to wear out, but it did nothing for the strength. Eye splices, hand splice, where do they break? They break right at the base of the splice. You could probably tell me what I'm going to say. As soon as you distort the structure of the cable, that's where they break. And it didn't matter, there's about a dozen different ways eye splices you can put in a piece of wire rope. Every one of them broke the same place. This new rope, new splice, not been pulled in, not worn in anything, but just new rope, new splice, pull it, that's where they break. Farmer's Eye 3-tuck. No difference in strength. The difference is in how much wear it will take before it fails. Because as we'll see here in a minute, the strength of that is not in the splice, it's in the farmer's eye. So here you can pretty much wear out those tucks, and you've still got the farmer's eye behind it giving you the strength. If you just do a 3-tuck eye, you wear out the tucks, and the eye goes, right? It's gone. So if you're running a carriage over that, if you're running it through something, farmer's eye 3-tuck. Farmer's eye 1-tuck. I was on an operation, they were standing up an intermediate support, big tree. They were going to use a piece of rope and had a farmer's eye 1-tuck in it. And I looked at them and I go, "Are you really sure you want to do that?" And they said, "Oh, yeah. Never been a problem before." So we took it back, we went back, did it, pulled them, and there again, Basically the same numbers. EIPS 78%, SWED's 89%. So what's the next most ridiculous thing? If you're going to do testing, you might as well test everything, right? So what's the next most ridiculous step we could take? Farmer's eye, no tucks. Okay? And I've given you the numbers so you don't have to guess, but you know, if I have people guess, they talking 50%, 60%, 40%. Farmer's eye, no tuck is just as strong as a spliced eye. It's not legal for a lot of good reasons. You can't use it operationally, it's going to pull out, you know, eventually it will pull out. But in an emergency, you've got a machine laying on top of somebody, you've got somebody trapped in a machine, you need an eye and a piece of cable, and you've got no way of splicing it in there. A farmer's eye is just as strong as a spliced eye. 10 minutes, okay, thank you. Okay, make sense? If you look at it, you've got down here, you've got 6 strands in the core taking the load, right? You look at the farmer's eye, 3 strands in the core go this way, 3 strands go this way. You've still got 6 strands in the core taking the load. All this wrapping stuff around each other does is provides enough friction to maintain the integrity of the eye. They're not actually adding anything. And that's why this actually tests out at least as good and sometimes better than a spliced eye, because you don't have, you're not distorting the structure of the cable as much. Okay? Another interesting thing we ran into, our Kiwis in the crowd will love this. This is a conventional straw line eye, right? You tie the hook in a knot and you put a splice in above it and you hook it back and you pull it, and that fails at about 60 to 72% at the knot. The knot breaks. Okay? Down in New Zealand they do it just a little bit different. Okay? Here you tie the hook in the knot and you bring the end back and you put the splice behind the hook. So now the hook is inside the eye. That breaks at 80 to 90%. So you can increase the strength of your straw line by 30% plus just by changing the way you put it together. And you know, we'll give the credit where the credit's due. That's the way they did it down in New Zealand. Whether they did it that way because they knew what they were doing or because they just did it that way and it happened to turn out that way, I don't know. We'll give them credit. We'll say they knew what to do. Okay, but it, you know, now this is in the BC WorkSafe BC manual. We didn't have very good luck on it on the test machine. Okay, it broke at about 64% and it cut off where the line went through the hook. Having said that, I've talked to loggers since then who they've run this system for years and they swear by it. As far as they're concerned, that's the only way to go. Yada, yada, yada. So I don't know. More testing. Another thing that's illegal, threaded strap. Thread one eye through the other. Comes out looking like a square knot. The splice broke. That knot did not fail. In fact, that knot, when the splice broke at 80, 85%, that knot, I drove a marlin spike down through the middle of that knot, halfway, got myself enough slack I could pull it apart. There again, in an emergency, it's something that you can use, okay? It's not legal. Brian didn't say it was okay to do that operationally. I didn't say that, but, you know, I still think knowledge is great stuff. Huh? Yeah, I'm on video, yeah. Okay. I know there's other terms for it, but a jump splice, passing splice, we've only done one so far. It was about 95%. We do it a little differently here in North America than they do it in New Zealand, but I think the results will probably be about the same. That's actually a legal splice in New Zealand, not legal up here. Molly, how strong is a molly? 6 wrap molly with the ends tucked in. It's 103% of the line it's made out of. So it's stronger than if you put a full molly between the 2 sections of your straw line, it's stronger than your straw line. 6 wraps, no tuck is 90 plus, still stronger than the splice. Okay, 5 wrap is about 82%. It's about the same as your splice. Okay. Questions? hopefully it gave you something you can use.
Thank you very much.